Hello everyone, welcome to the class of algorithms. Let's dive into the fascinating world of dynamic programming. Imagine you are on a quest in a vast kingdom filled with challenges that seem unsolvable for you. Now you face a series of puzzles where the solution to one affects the next. What will you do in that situation? Fear not. Dynamic programming is your trusty magic wand, allowing you to break down these challenges into manageable solutions or some pieces. It will save your time and effort. So, in this class, we will embark on an adventure where algorithms become your friends and efficiency is your ultimate goals. Now, what is dynamic programming, right? So, first, what I have said, you have been given some complex problem. So what will you do? You have to solve this complex problem. So that is the idea of dynamic programming. You can also call this as DP, right? Okay. Now, there are some steps to solve this complex problem using dynamic programming. So how will you solve? So, first step is you have to break it into some pieces, or you can also call it as subproblems, right? So in a simpler way, I can tell that there are some puzzles. Okay? You can also call it quotient. So this is all in one quotient, or you can say it is the bigger one or the bigger picture of the quotient one. And to be more specific, maybe this is the sub-quotient, okay? Let's call it SQ, sub-quotients. So this is the big picture. Now what will you do? You have to break this quotient into some sub-quotient or sub-problems. You have to identify, you have to read the quotients more depthly, and then you can create a sub-problems by some pieces. So that is what we have done now. Now, what it will do, or why will you do it by dynamic programming, right? So the most important thing that it will save your time and effort. Now, so what is dynamic programming, right? So dynamic programming is to solve complex problems by breaking them into simpler sub-problems, what we have discussed. So that is all, right? Now, what is the useful of dynamic programming? So it is mainly used for optimization problems. Suppose now you can tell me what is optimization problems, right? So optimization problems, right? Optimization problems. Optimization. What is optimization? Now we will discuss about it, okay? Let's discuss it. So suppose you have been given some puzzles, right? The puzzles, now what will we do? We will break the puzzles into some subproblems. Subproblem 1, subproblem 2, subproblem 3, subproblem 4, and so on. Like subproblem 7 to subproblem 7. What I have meant. Okay, now what we have to do? We have to choose the best solution from the puzzles. That is your first priority. What? To choose the best solution from the subproblems. Now, after choosing the best solution from the subproblems. Suppose you got S5 as your best solution, but not only S5, you have also got S6 and then again S3. So this tree is your best solution. Now the question is, how can you get three best solution and how will you solve it, right? And what will be your problems, or what will you face while solving these subproblems? So we will do, when you will solve this problem, you will see some overlapping problems. Like, if you choose subproblem 3, then you cannot repeat the subproblem 3 another time. Or if you get subproblem 5, then you cannot take the S5 again in another solution. Okay, let me give you a picture of it. Okay, clear picture. Suppose this is your best solution, BS. Okay, so one time you have got S3 and another time you have got S5, and this is suppose your S6. Okay, I have written this tree like a picture. Okay, now what you have got, suppose in some tree you got the S6, then again S6. So what we have got, we got repeated times of subproblem 6, right? We got two solutions in one tree. So what we have told is we cannot repeat the solution. What? We can't repeat the solutions for multiple times. Okay? So we cannot repeat the solution for multiple times, as I have just told you that if you have got S6, you cannot repeat the S6 for the multiple times. Okay, so now let's see. So what is that? So let me give you a clear picture. That is, we have got that blue, right? Blue, but we got blue for multiple times. How? Here we again got blue, then again you got pink, again you got pink, white is 3 times, 1 2 3 and again 4. So you have seen no overlapping. Okay, no overlap. If you got one solution, the solution must be this one. You cannot repeat that solution for the second time. Okay, now let me give you another example. Okay, so let's begin. So you have been given a complex problem. Now what you have done, you break them into pieces, you break them, and then you got subproblems, right? So when you will solve these subproblems, I told you you will face some problems, right? So to overcome that challenges, we have to go through 2 steps or also 3 sometimes, right? Okay, so what are those 2? That is, you have to save that solution into a table, or you have to save that in a memoization. Okay, what is memoization? What is memoization? Okay, we have to save it on a memoization or on a table. So we will not call it a table, we will call it a memoization. So what is our memory do? We store our all day things into our memory, right? So it is like a memory of a DP. So we will store that solution into that memoization. Okay, now there are 2 types of approach. One is top down and another is bottom to top. So what is top down? Okay, so top down is also called as memoization. Okay, it is also called as memoization. So this technique involves solution or solving the problem recursively and storing the results of sub-problems to avoid redundant calculation. So what is redundant calculation? What I have told, you cannot repeat the solution for the second time. So this is what memoization does. So suppose you got S1, so you memorize it. Now if you got S1 for the third time or the second time, you will see, no, it has already been stored in the memoization, right? So that is what top to down does or memoization does. What is stabilization? So it is the same as memoization, it is just a bottom to up. Okay, it is bottom to up. So in this approach, we solve all possible sub problems and stores their results in a table. So what we do, tabulation makes table to store your solution, and memoization, they just store it in anything, but that is not in a table, right? Okay, now let's hop into the next one. So you can see, is overlapping or yes or no. We have already discussed that we cannot do or solve multiple times, or there cannot be an overlapping subproblems, right? So if you found an overlapping, then you have to find the optimal solution, right? So how will you solve the optimal solution, or how can you overcome the overlapping in dynamic programming? So that is where the 0-1 knapsack problem begins. So if you find any overlapping, then you have to find the optimal solution. So how can you overcome the optimal solution, or how can you find the optimal solution? Then you have to do it by 0-1 knapsack problem. 0-1 knapsack problem is that is, you can take the solution or you cannot take the solution, right? So 0 means you can't and 1 means yes you can. So that is take means 1 and not take means 0. So after doing the 0-1 knapsack problem, what you have to do is you have to make a DP table. So what is a DP table? It is a method to solve 0-1 knapsack problem. You cannot just do or solve the 0-1 knapsack problem in any time. To solve the 0-1 knapsack problem, you have to find the DP table, or you have to draw a DP table where you can find the 0, 1 knapsack problem, or you can solve it. So after doing the DP table, then you can find the optimal solution when you got a overlapping problem, right? Okay, now if you don't get the overlapping problem, which is no, then you have to solve it by divide and conquer, which means lastly you have to do quick sort, and the last one is merge sort. So you can do it in both ways. You can also do it by quick sort or merge sort. Okay, so thank you for your attention. If you got any problem, then please comment down below. I will try to make a short video on your specific problem, and please like and subscribe. Thank you guys. Be well.